Hey guys, today's video is about data dispersion. We'll go through 3 commonly used measures of dispersion, which are range, IQR, variance, and standard deviation. To make the video short, I would introduce range and IQR in this video and use a separate video to introduce variance and standard deviation. To begin with, what is dispersion in statistics? Dispersion is also called spread or variability. It describes the extent to which a distribution is stretched. For example, it's obvious that B spreads more than A, so we'll say distribution B is more dispersed. The first measure of dispersion is range. Range is the difference between the largest and the smallest value in the data set. If our data is 1, 3, 5, and 20, the range is 20 minus 1, which is 19. Range is the simplest measure of spread in statistics. However, there is some trade-offs between simplicity and reliability. Range is sensitive to outliers, which are extreme values. Moreover, it doesn't use all the data, so the reliability of range is compromised. Say we have data 5, 91, 95, 98, and 99. The range is 99 minus 5, which is 94. However, 80% of data are above 90 and below 100. The data 5 should be considered as an outlier, and the level of dispersion is exaggerated if we use range. Next, we will introduce the concept of quantile and quartile before talking about IQR. Quantiles are values which divide the ordered data into equal-sized subsets. In fact, you can divide the data into as many subsets as you want. Quartiles are 4 quantiles. Namely, the data is divided into 4 subsets, and each subset contains 25% of data, which is 100% divided by 4. For example, the blue area in the graph contains 25% of data since it denotes the data points below Q1, which is the first quartile. The pink plus blue area contains 50% of data since Q2 is the second quartile. IQR, which is interquartile range, is calculated by Q3 minus Q1. In other words, IQR is the range of the middle 50% of data. However, IQR is better than range since it's not affected by extreme values. In fact, we deliberately ignore the first and the last 25% of data to reduce the impact of outliers. Still, IQR has disadvantages that it is most reliable with symmetric data. For example, we have these 2 distributions. One is symmetric and another is asymmetric. The orange area is the middle 50% of data, so IQR would return the range of this area. IQR works fine with symmetric data. However, for the asymmetric data, IQR totally ignores the long tail on the right-hand side. The thing is that the tail might not be outliers and should be considered as part of the distribution. Therefore, totally ignoring this long tail could cause bias in later analysis. Since we now understand the concept of quartile, I want to briefly introduce Boxplot so you know how to interpret the numbers on it. There are 5 numbers on the Boxplot, which are minima, quartile 1, quartile 2, quartile 3, and maxima. Fortunately, we can infer the distribution of data from the Boxplot. First, the data is skewed to the left, since the distance between Q2 and minima is larger than the distance between Q2 and maxima. Q2 is the median, which is an unbiased center of data. So, the distribution will be something like this. We can always convert Boxplot to density plot, and the difference between the length of red and green line indicates how skewed the data is. Second, the spread of data changes as the value changes, which is what we call heteroscedasticity in statistics. To be more specific, The blue line on the top is pretty short, meaning that 25% of data is close to one another. However, the yellow line is quite long, meaning that 25% of data between Q1 and Q2 is spread and variable. A modified version of Boxplot is adding the outliers. These two dots in the bottom are outliers. The position of bottom whisker also changed. The distance between Q1 and the bottom whisker is 1.5 IQR. So, the position of bottom whiskers become Q1 minus 1.5 IQR. In the box plot, the outlier is defined as values below Q1 minus 1.5 IQR or the values above Q3 plus 1.5 IQR. And the whiskers of minima and maxima will change correspondingly. The whiskers will only change when there is an outlier on its end. So, if there is an extremely small value, the bottom whisker will change to Q1 minus 1.5 IQR. But the top whiskers would remain the same. So, that's the basic idea of range, IQR, and box plot. Thank you for watching my video and see you next time.